The University of Wisconsin-Madison campus has a large multimodal system including bicycles, cars, buses, mopeds, and pedestrians. All of these modes of transportation have to work together in order to function as safely and efficiently as possible. Because of the large amounts of traffic, many problems may arise that can increase delays and lower the level of service for many individuals in different areas on campus. We will be analyzing two of the busiest intersections that, as a whole, may be considered one of the university's biggest transportation issues on campus. These two intersections are located at Charter Street and Linden Drive and at Charter Street and Observatory Drive. These intersections create a large problem because they become extremely oversaturated between the passing periods of classes and remain relatively constant at the other parts of the day. This means that with the high amounts of pedestrian traffic, significant delays are experienced by the vehicle traffic. This can lead to a major safety issue with many impatient drivers and large amounts of pedestrians trying to cross the intersections. Therefore, we will collect and analyze different data from both of the intersections and conjecture potential countermeasures and solutions to try and minimize inefficiencies for this unique transportation problem on campus. Hi, we're Team TBA. I'm Sarah Watry.
I'm Taylor Blake.
I'm Tim Kloxheim.
And I'm Zach Lemke.
Traffic volume counts were collected at both intersections. At the intersection of Charter and Observatory, the peak volume for pedestrians was 476, whereas peak volume for vehicles was 106. This led to peak hour factors of 0.365 and 0.79, respectively, for each. At the intersection of Charter and Linden, the peak volume for pedestrians was 876 and for vehicles was 72. The peak hour factors were calculated to be 0.359 and 0.98 respectively. At both intersections, we saw extremely low peak hour factors for pedestrian flow. This means very high pedestrian flows over short periods of time. This causes the large vehicle delays that were directly measured. The average vehicle delay at Charter and Observatory was 38.2 seconds. The delay at Charter and Linden with no control was 32 seconds, whereas the stop-controlled portion was 51 seconds. The delays corresponded to a level of service E for both intersections, which is unsatisfactory.
We had the opportunity to interview a Union South warehouse manager, Mr. Sabi Ataya. He stated that a lot of deliveries are scheduled around passing time just to avoid traffic delay. Delivery drivers struggle with jaywalkers and uncooperative pedestrians on a daily basis. Also, hill stops are tough for delivery drivers to navigate when they are on steep grades.
We interviewed several students on campus as well. The most common response was that they know firsthand that both of these intersections are a problem and that something needs to be done to improve them. However, they do not know of any specific solutions to try and fix it.
Since safety is an important part of transportation engineering, we decided to pull 5 years' worth of crash data from the WisTrans portal database and compile them into a crash diagram for both intersections. At Charter and Linden, we see very few crashes, less than one crash per year, with no obvious safety trends. However, there was one vehicle-pedestrian crash. At Charter and Observatory, we see the same trends. Slightly more crashes, only about one crash per year. However, we see two more pedestrian-involved crashes. So the takeaway from these crash histories is that there are too many pedestrian-involved crashes at these intersections, which can be extremely dangerous, so focus should be placed on eliminating pedestrian and vehicle conflicts. For our first possible solution, we decided to investigate pedestrian tunnels. The main issues for these intersections were large delays for vehicles and multiple pedestrian vehicle crashes. The best way to solve these issues would be to move pedestrians out of the way of vehicle traffic. This leaves us with a pedestrian bridge or pedestrian tunnel. Due to the fact that this is the main delivery route, however, bridges may cause vertical clearance issues for trucks. A pedestrian tunnel doesn't have these issues, so it is the better option in this case. We would place tunnels at the busiest four crosswalks shown here. The advantages to a pedestrian tunnel solution would be that it would remove almost all pedestrian crossings, it would be a permanent solution, and it would add to the overall flow and connectivity of campus. However, the costs outweigh the benefits for this solution. Tunnels would cause accessibility issues for some students, and a tunnel is extremely cost prohibitive at $2 to $10 million per tunnel, according to the Federal Highway Administration.
Our second solution is a combination of crossing guards and jaywalking barriers. A human crossing guard, or someone who's simply directing traffic, could help increase efficiency at both Charter Street intersections. This would help get vehicles through the intersection. This would solve two major issues: pedestrian safety and vehicle delay. There have been 3 pedestrian vehicle collisions in this corridor within the last 5 years. Having a crossing guard to maintain safe operation would hopefully eliminate those types of crashes. These intersections have a level of service of level E during passing times. A crossing guard would introduce gaps in the pedestrian flow during busy passing time periods as needed to reduce vehicle delay. Using estimates from where crossing guards are in use, this solution would only cost $100,000 per year.
In addition to the crossing guard, we are proposing jaywalking barriers. These barriers are a familiar sight to many on campus. The university uses these for many different reasons, and they are not always noticeable. The benefits of these barriers include preventing jaywalking, channelizing pedestrian traffic, and protecting pedestrians. Jaywalking is a major safety issue as it violates driver expectancy. When driver expectancy is violated, drivers take longer to react to the pedestrian. This puts pedestrians in greater danger. For the most basic barriers, it would only cost about $150,000. Putting in jaywalking barriers along Charter, Observatory, and Linden is a relatively inexpensive way to improve safety at these intersections. Therefore, the combination of crossing guards and jaywalking barriers is our recommended solution to this problem.
With all the forms of transportation, the systems in place are not perfect. Perfection is an unattainable goal for problems within transportation engineering, but that does not mean it cannot be strived for. The problem that was researched this semester is something that should be fixed. Count data, crash analysis, interviews, and a selected final solution from a couple of proposed ideas were all accounted for the completion of this project. The solution that was the most cost-effective and easiest to implement, the crossing guard with the jaywalking barriers, offers the best choice for solving a problem that occurs every hour during the week.